p.m., so we'll just let a couple more people jump in. Like I said, if you're looking to get your CEUs, please email Allie at allie.crampton@tn.gov. I'm going to post it again in the chat section. And if there's multiple people on one device, just email her one single email with all the attendees' names and their license numbers. So I will post that one more time if you haven't seen it right now. All right, let's get this nutrient optimization party started. I am Mark Valencia. I'm with the Tennessee Department of Environment and Conservation, Office of Policy and Sustainable Practices. That is a mouthful, but that is my group. And welcome to the Optimizing Biological Nutrient Removal in Tennessee Wastewater Treatment Plants webinar series. This is the 7th and final webinar of the series. Once again, I'm Mark Valencia. I'm here with TDEC, and I will be hosting this show for you all this day. We have really enjoyed hosting this event, and we hope you all have found it to be educational and interesting. I've also found it very educational and fun. You're all probably already aware of this, but please note that you have been muted upon entry. You are welcome to unmute yourself and ask questions. Another way to ask a question is through the chat box. If you look over to your right, top right corner, there's a little section that's called chat. Click on that. You can field all your questions in there, and you can get those questions addressed to the presenter. We know that our presenter likes when we jump in with questions, so feel free to ask them anytime. And there will also be some natural stopping points for questions as well. Do not send the questions directly to any of the presenters because they won't be able to see it. We ask that you use those chat features in the Q&A sections, and that's where we'll be able to see all of those. Also, if you will, let's take the time to check out the yes or no feature. Sometimes we'll ask yes or no questions, and these questions you can participate by looking over again in the participant section. You'll see some little symbols. There's a hand symbol, a check symbol, and an X symbol. Please use the check symbol as yes and the X symbol as no. Just for a quick practice, someone just please, let's see if you all can click the check mark, the yes symbol for us. Awesome. I see a lot of y'all participating. So please note, when we're done with that question, you'll have to unclick that button or it will remain on. So if you ask another question, that may be, you may still see that. So please uncheck them now and we'll continue on. Our presenter, again, wants to know that he enjoys your engagement and prefers to be interrupted with questions. So please feel free to unmute yourself or field some questions through us, and we can get those questions out to him. We'll have several polls throughout the day. The second poll question will be in the middle of the webinar, and during that time, it'll also be a great stopping point for a quick break. We were able to get approved for 1.5 CEUs for each of these sessions for your wastewater license in the state of Tennessee. For folks that are viewing this training as a group, we will need to email the names and license numbers to Allie Crampton. Again, that email address is posted in the chat section, and we will include that with the course roster. This session will be recorded and we will make it available on our Tennessee Plant Optimization website. Also, if you have Microsoft Teams on your computer and you feel WebEx is running slowly, closing out Microsoft Teams can help with the more fluid response time with the WebEx application. So I'm going to pass it on to Karina, and she's going to do the introductions.
Well, thank you, Mark, and thank you, Allie. Thank you, everybody on the webinar today. I'm Karina Bynum. I am the coordinator for the Tennessee Plant Optimization Program, and I'd like to say a few words about where we are today and why we're here. So this is our last session of the webinar series, and we have heard a lot about nutrient optimization, nitrogen removal, phosphorus removal, as we focused on using the plants as they are without necessarily being designed for nutrient removal, and doing as much removal as possible in the plant with existing equipment. So I want to do a little bit of philosophical here. So working with two basic premises. First premise is engineers do not like their designs to fail. If you know an engineer, you'll know how to push his buttons. This will definitely work on them. And for operators, they do not like their plants to be unpredictable. They really don't like that. So I imagine, if I'm not right, you speak up now, but that's what I have experienced as I work with the operators. So how do engineers design for nutrient removal? Right? Remember what they don't like? They don't like things to fail. So they start with conservative assumptions. So if they don't know something, they'll assume something very conservative. And when they design for the worst case scenario. Again, quote unquote, engineering guarantee, right? They design to meet limits. And most of the time, the limits are expressed in milligrams per liter. So that's what they're used to designing for, not necessarily as annual loadings or average loadings or rolling averages or anything like that. They're used to milligrams per liter. And then there are always safety factors for the unperceived circumstances and operational variability. And then at the end, they always round up for buildability and additional capacity. So that's how engineers design things. And they do that for nutrient removal too. What does that mean? And what do they leave on the table when they do that? Well, operator knowledge. There is an investment made into the knowledge of the operator, and they're also building up their skills through this learning, their ingenuity and ability to understand and adjust their plan is also building up the experience from observation. All of that doesn't come into the design. And what is also possibly left on the table is the operator's ability to adjust the system based on data. This is where we could improve the design of the engineers for better nutrient removal. So when we leave that on the table, what does it cost us? Well, it will be millions of dollars per project. It will be billions of dollars in the state of Tennessee. So what is Stata doing about that? Division of Water Resources fully supports the operations-based approach to nutrient removal. That's why we built this Tennessee Plant Optimization Program, and we provide the facilities informed oversight and permitting and enforcement discretion. We also support the technical aspects of nutrient removal optimization. Hence, the series, any training we can provide for you, technical assistance, peer-to-peer experience. We can put you in touch with anybody else that has a similar plant and optimized with us in the past. We also loan out diagnostic equipment, and we are looking at energy efficiency opportunities at the participating plants. So while nutrient optimization doesn't work everywhere, we are on this journey with you, and we have your back. So that's what I wanted to say. And without much further delay, I do want to welcome Grant Weaver to talk to us about some very specific plants and how nutrients are treated in each of the plants. And I also want to express appreciation for the bravery and interest of our added panelists. We will have some case studies and their operators talk directly to us about their plans. And that's the most exciting part to me. So thank you, everybody. And Grant, the floor is yours, and thank you for carrying this one.
All right. Thank you, Karina. I'm messing around with the icons at the top, trying to get them to shrink on me. Maybe it'll happen. There it goes. Soon I'll find the video, but we'll save that for later. I guess to summarize, what I just heard you say, Dr. Bynum, is that you support this effort and you're encouraging people to experiment with their plants and see what they can get out of them, and then to take that knowledge and apply that to whatever engineering solutions may follow near term or longer term. So thank you for that. And any of you have any questions about that, what the HEDEX position is regarding this optimization that you're going to be hearing about here in a few minutes, I think you got the message, and it's a great message. So we've had 6 weeks of sessions. We had a last-minute change in plan, but I see that any number of you were able to accommodate that, and I thank you very much. That was all on me, and the change was made to accommodate my needs. So thank you for allowing that. Today's it. Today's the last session, and the less of me talking, the better. So let's do a polling question, and then let's get right into some of the plants here in Tennessee and hear from the operators.
All righty, I'll set this poll up right now. So the question is, have you heard about plant optimization before these training series? Looks like we're steering to finished. That's pretty interesting. So give it a few more seconds and we'll close this out. I'm going to hand it back over to you, Grant.
All right, thanks, Nick. We're going to do some handoffs here. I'm going to grab it and then pretty much immediately hand it off again. Well, that's good that there's a lot of familiarity with the Tennessee optimization, nutrient optimization program. During the break, I'll put up a couple of slides about that program, but it sounds like something that we have a lot of familiarity with already. So let's get the show on the road. Let's go to Dixon County. There's 2 treatment plants. We've got Nick Tatum in the green room here, ready to step out. Nick, I'm going to hand it over to you. Take it away, my friend.
All right. Can you see the screen now? All right, I'm Nick Tatum. I'm with the Water Authority of Dixon County. I'm the wastewater treatment manager. We operate 3 different wastewater treatment plants. We have White Bluff, Jones Creek, and our Fairview. So I guess we'll start with White Bluff. We haven't really done just a whole lot there. We've done off cycles. Our phosphorus is just kind of is what it is. We haven't tried a whole lot there other than the DFAs, using the digester to do that. And we didn't have much success, but that was many years ago, so I don't know. We fed about 300 gallons a day into that, and our flow was about 300,000. I'm not sure really what
what the issue was, but we didn't have much success. So I guess it's probably best to show the wastewater comes in and the start of the ditch. I guess you can see my mouse there. Goes around all cycles. We leave one rotor running all the time, and the others we alternate and leave about 12 hours is our best that we've had to get the nitrogen on down. From the center of the ditch, it goes to the clarifiers, and then on to the contact chamber, and then back to the system. Here's our nitrogen numbers. When we first took over Wet Bluff in 2015, we had in the 20s of nitrogen. We started with the eye cycles and changing mix liquors and all that, just trying to get everything balanced out. It was not in the best of shape when we took over. So we've been able to get on down with some better numbers. And then there's the phosphorus. I guess we'll move on to Jones Creek. Jones Creek, we have had limits for quite a few years on nitrogen phosphorus. So we've researched our mix liquor back to start over the beginning of the ditch. We've done that for years, and never really had a phosphorus issue. It seems to stay pretty low. So the way this one works, it comes in through the bar screens, up the screws, travels through a pipe over to the ditch, and comes in right here on this first outer ring, goes around, and eventually leaves the center of the ditch. So when it leaves the center, it goes through a pipe underneath the ditch and goes all the way to the clarifiers. Area right here has the ability we can flood that with the flow from the ditch, and we pump that back over in to the ditch to refurb and to get our nitrogen removal. Then from there it goes to the clarifiers. And then on to the contact chamber. The schematic shows what all is happening. There's some of our nitrogen numbers. We found that we get nitrogen a lot better if we run all the ditch motors with dried off cycles, but we had better success with everything running. And then there's our phosphorus. We do have septic haulers. I think that may be a little bit of the VFA coming in. There's also the ditches a 15-foot deep. So we think it's got some zones. Take it on down and get some of that going on too. That's it.
All right, Nick, I can have some questions. This is Grant, and we'll see if we can generate some other questions from the audience. So let's start with Jones Creek. Can you back up a couple of slides and maybe look at the plant? One more. There you go. So can you walk us through that again? So the influent goes around that outer ring. Do you do any measurements in there? Do you have any sense on what the DO or ORP or any of that is?
The DO's running usually about a 0.3 out there.
0.3. You got a real low DO.
Yeah, we're checking that usually over here right before the rotor.
Right before the rotors, okay. So you've got 2 pair of rotors in 4 places then on that outer ring, is that right?
Right.
And your flow through the plant is about how much?
We're averaging about 3 million.
About 3 million. And how big is the volume of that ditch?
It's 3 million.
3 million. Okay, so the wastewater spends a day in your plant, right? Okay. And then plus whatever time's in the clarifier. So during that time, what kind of a mixed liquor are you operating at?
25 to 28.
Okay. All right. So you got a lot of pounds. You got a lot of bacteria, 15 feet deep, 3 million gallons. Your influent, is it pretty consistent or is it change in strength?
It's pretty consistent. 150s. Yeah, I mean, some days we'll have higher, lower, but
So about 150 BOD coming in?
yeah.
Okay, so you've got a pretty good, I mean, better than many influent BOD. The more BOD, the better, right? That's what we've been talking about. So you got this outer zone with low oxygen. So what would you guys call that? You call that an anoxic zone or an anaerobic zone?
We just got the outer ring.
What do the bacteria call it? You don't listen to their chatter, I think. All right. So you've got a low oxygen, and you measure the ORP fairly near the top, right? The DO, when you measure that DO of 0.3,
Yeah.
you don't go down 12 feet to see what it is down there.
Brent Ward came at some point or another, and we did, had to weight it and put it down there, but the way this thing moves, it's really hard to get it down there. Bring it out 12 feet, and it's going to be 12 feet down the ditch. See it come up.
So the suspicion, though, is that down there on the bottom, you probably got some places, given the vast expanse of that outer ring, that has some sludge blankets in it, or at least some even considerably lower dissolved oxygen than the surface.
Right.
And we talked about your plant a little bit yesterday, and so one thing I know that others may not know is up at the top there, that concrete perimeter wall is just 2 or 3 feet above the ground level, and down there at the bottom, it's quite a ways up. And you can see that by the stairway there, just north of if that's north, just above the trucks parked there. Yeah, right there. There are a lot of steps. So you can't really monitor what's going on in a good portion of that plant, right? You can go on the catwalks, and then where the ground level is close enough, you can get near the outer wall. But otherwise, you've got huge zones that you really can't monitor. And then, like you say, vertically, you can monitor near the surface, but not real deep. So given those kind of phosphorus numbers you have, which are pretty doggone good, right? Your phosphorus was 1 or less, at least the rolling average, as I recall from that graph. So there's got to be phosphorus removal somewhere. We talked about the science. I'm going to assume that you're getting VFA production and interaction with the phosphorus removing bacteria in places in that outer ring. And that's probably Brett was poking around, Brett Ward from University of Tennessee, when he was out helping out, he was probably looking for something like that himself, right? Okay, then it moves to the inner rings, ever more inner towards the bullseye in the middle, and then you explain how it pumped. Can you explain that again to everybody?
So there's a weir on this far side that falls over that weir, and there's a pit in the middle. pipe runs underneath the ditch over to this area here, and eventually down to the clarifiers box here, and the clarifiers. But that pit, we set up some pumps right here in this little building. Pumps directly out of that pit, gate in that pit that we can plug for that area. Water coming out of the ditch over into that area, pump it back in. There's the discharge.
Okay, and about how much do you pump? Do you have any quantification to that?
It's, I mean, it's got a flow meter on it, but they upsize that pipe so much that it doesn't stay full, so has a hard time reading, but thinking it's about a minute there that it's pumping back.
About how much?
1,500 gallons.
1,500? So that's about 2 million gallons a day. So that's a little bit less than your flow through the plant, correct?
Yeah.
So those inner rings, as it gets on these orbital ditches, the volume of those inner rings is much smaller, yet they still have a lot of aerators, so they become more aerobic. They become a higher DO as you get more towards the middle, right?
Right.
So you're getting your ammonia removal in the middle two rings. The ammonia is converting to nitrate, and then you've got that recycle system. So that sends the nitrates back into that outer ring, and that's how you're getting your nitrogen removal, I would presume, right? Okay. And so if you pump too much back into that outer ring, which is probably not really possible, given just looking at the thing, it's in theory you could pump so much high dissolved oxygen from those inner rings that you could start to raise the DO in that outer ring too much. But if you pump too little, then you're creating the nitrates, but not bringing them back into that outer ditch. And instead of going into that outer ditch to denitrify for the nitrates to be removed, the nitrates that are produced in the middle two rings would find their way to your clarifiers and go out in the final effluent. So that's why you have such good nitrogen numbers. This thing's really dialing it in. So I guess I'll be visiting in a couple of weeks. What would you hope to get out of this visit? What would make for? I mean, this is a pretty good running plant. There isn't much to do there. What would you hope to do better there? Not much.
I'm not real sure. I know we struggle when the temperatures change. So front end of the nutrient season, when we first start researching, we struggle to get it in, and then right at the end, right when the temperatures start to cool back off, that's another struggle.
Can you do a graph and show us what you're talking about? Would it show up there?
On the graph.
So yeah, go ahead.
Kind of right in there, it starts to come up, and like here and there. Usually right on, in October, and then May and October, those are kind of cutting it close.
October, yeah. And both go up, huh? At least that year in 19. Do you change your DO settings or your recirc rates throughout the year? They pretty much stay the same.
Yeah, we usually change the DO. We usually turn off the recirc during the winter time. We don't have a limit, so we but then in the winter when we get rainfall events, we can't run it anyway, so it's just easier to turn it off. Because during high flow, you got to turn it off anyway. So it's just easier to turn it off and leave it off during the winter to drain on it. But
Okay, that's interesting.
myself, we usually start in April, trying to get everything dialed in then, and then do it from there.
All right, so let's look around this January 20th mark on the bottom of your nitrogen graph. So if you're turning that internal recycle off a couple months before that, then your nitrates, fewer of your nitrates are going back to that outer ring to be removed. So we can create the story, right, as to why that might go up at that time of year. Can you flip to the phosphorus graph and take a look at that one? So January of 20, look at that. Now that you don't have all that extra dissolved oxygen from the internal recycle going to that outer ring, the dissolved oxygen drops even further, becomes more anaerobic. As it becomes more anaerobic, it's a better phosphorus removing machine, that treatment plant of yours. So can you flip back and forth between these so all of this can look? It's pretty, to me, it's kind of remarkable. There you go, right there. And go to the other one. So there's a correlation here. That's something we can play with a little bit. Maybe we'll talk about that in the weeks to come. What's the tug and pull of the nitrogen and phosphorus removal? We'll see if that story goes elsewhere. Let's look between July and January. We see the phosphorus go up. July, August, September. It'll be about September when you had that high number of 2. What's July, August, September? What's September of 19 look like for nitrogen level? Very low. Okay. All right. There's something to look at. It's a very well running plant. Those are great nitrogen numbers, and the phosphorus numbers ain't shabby either. But if there was a desire to get maybe a little better phosphorus, maybe at the expense of nitrogen a little bit, bump the nitrogen from 3 up to 6 or so, 5 or 6, might be able to pull phosphorus down. So this is a plant, I think, where you're going to have an ability to choose your nutrient that you most want to go after and operate accordingly. So it was a great story. Any of the Bree or Mark, is anybody from the audience weighed in with any comments or questions?
Nothing yet.
Yeah, I'm not seeing any in chat or Q&A.
Okay, well, we certainly welcome them if anybody else wants to jump in. Otherwise, I'm going to back these guys up, ask them if they'll back up to the White Bluff plant, and let's do a similar look at that one. That was really good. Wish we could do a round of applause from the audience for the presentation, because that was great.
So I'm pushing this back to you, Grant?
No, stay with them.
Okay.
So White Bluff, we kind of ran through that one fast too. So can you flip us through you don't have what do you have for data on that one that we could look at?
I've got nitrogen phosphorus.
All right. All right, so phosphorus quite a bit higher here. This would be more, in fact, this is on the high side of what we'd see in a lot of plants. I'll tell you what, just looking at these data right here, I'm going to speculate. And, you know, when you speculate, you're often wrong. So odds are I could very well be wrong. But you've got some pretty high numbers. If you're getting much more than 4 in your effluent, you're probably releasing quite a bit. But what it indicates to me is you've got a strong anaerobic condition, but you're not getting the uptake for some reason. And look, when is that happening? That's happening, these are quarterly samples, right? So these are happening in your July, what was the other one? July, August, September. July and October. 19 is a pretty good year. It only spiked up to 3.5, but the other 2 years went pretty high, quite high. Okay, let's go to nitrogen, see what happens at that time of year. That's also high. Well, relatively. All right, so we're going to want for nitrogen, the problem with looking at total nitrogen numbers is we don't know how much of it is what. How much is ammonia, how much is organic, how much is nitrite. But as one who likes to speculate, I'm going to ask you, how's ammonia removal at White Bluff?
Very good.
Very good, right. So you've got year-round ammonia removal, right? No problem with ammonia.
Right.
Okay. Well, ammonia and then organic, ammonia plus organic is the TKN. TKN plus the nitrate is your total. So your organic really shouldn't change unless you're blowing a lot of solids out. You're blowing a lot of solids out, White Bluff?
No.
What's your effluent TSS? What is it, single digit? Here's what I'm asking. If it's 10, say, see about 12% of living organisms is nitrogen, organic nitrogen. So
In December, it ran on 1.8.
1.8. Okay, so even if it was high as 10, your organic nitrogen would be about 1 in the TSS. So you don't have much ammonia, you don't have much organic nitrogen, so your numbers here are the nitrate. The nitrate is you've removed the ammonia, but you haven't denitrified. So, so you put enough here to remove the ammonia, but you're not denitrifying. It looks like your phosphorus may be the other problem. It looks like you may be getting a lot of phosphorus released somehow, but you're not getting all the uptake. So let's go back to look at your picture of your plant, see what you got here. Okay, so tell us about that orbital ditch there, if you will, how that one works.
Alright, so the influent is pumped from the lift station, comes in this box here, wash cream, jumps into the ditch there, goes through this rotor, around, that one, gates right here to get that cream around, and then it gate right here. Leaves in the middle. What about foot speed clarifier?
Is there a recycle on this one?
No, there's not.
There's not. Okay. And looks like you've got about twice as much rotor on that inner ring as you do the outer ring. Am I right on that? The rotors look like they're twice as wide as the ones on the outer ring. See what I'm saying?
Yeah, they are.
Okay. So the inner ring has a higher dissolved oxygen. And you've got no internal recycle, so you don't have a real good opportunity to drive that nitrate down. There's no, what do you have for dissolved oxygen in those rings? If you have that number. I'm asking a lot of stuff and you've answered every question. If you don't know it, that's fine.
I don't know what we're running there. It's Mike Brown's on. He might be able to answer that one.
All right. So you really don't have much going on for phosphorus opportunity there for the release. I could be dead wrong. How are you dewatering your sludge here? Or what are you doing with the waste sludge, I should say?
We put it on the drying bed. Sludge digested here. We will supernax some, but it usually just runs most of the time. If you get the solids too thick, you have trouble walking going on the drying bed. So.
All right, so do you decant now is it aerobic digester or do you have the air off?
It's aerobic.
It's air runs all the time?
Yeah.
Except when you decant it, you turn it down, let it settle.
Right.
And how about your beds? Tennessee weather, it rains so doggone much there. Is there a time of year that you don't bother putting it on the beds and time of year where you do bother?
There's some times during the winter we'll get a septic hauler to come and he'll pump it. It's to Jones Creek plant, for instance, Jones Creek. Yeah, but we do most of it on those beds. Usually you can put it on one day and all within the next day or two.
Oh, is that right? Wow. Have you attempted to correlate what you do with the sludge decanting or putting it on the bed with what your nitrogen or phosphorus numbers are?
I have not.
I wonder if there might be some kind of relationship that, when you're hauling the Jones Creek, you're not releasing all that phosphorus, so you might have better numbers on those days. All right, so what do you have for in-house lab equipment? Do you have a spectrophotometer that you do? Okay, great. So we'll work on that. We'll talk about that. Maybe do some, the whole game here is cause and effect, right? What's making for those good numbers and what's making for the bad numbers? And it ain't voodoo. There's some science there. It may not be easy to figure out, but, we're supposedly the ones with the brains and not the bacteria. So maybe we can do a little cause and effect and see what's going on. So that's kind of my thought there. And anybody, any of the observers here have any questions or comments for these folks?
We had a question in the chat. It said, you mentioned your discharge limits change. Why is that?
So our limit for nitrogen and phosphorus is only during the summer months. During the winter months, it's report only. Guess you can think why they set ours that way.
What are those numbers in the summer?
It would be 4 for total nitrogen and 3 for phosphorus.
What is it for nitrogen?
4.
4? Your limit is 4.0 milligrams per liter?
Yeah.
That is a crazy low number.
4. And phosphorus is a 3.
Go back to those graphs if you would for just a moment, especially nitrogen.
On Jones Creek,
Oh, that's Jones Creek. Oh.
Fairview, or, White Bluff is report only.
Ah, I got confused. Okay. Wow. Well, you're meeting, I mean, that's a very low permit limit for Jones Creek, and the fact that you're meeting is compliment to you guys. That's a tough number to meet. Tightest one, we run some little plants, and the tightest one we run is 7, and we think, oh, we can beat that pretty handily, but I wouldn't like a 4. So, any other questions or comments? Anything any of you want to say? Nick, Kevin, Mike, anything All right, well, I think I'm ready for you to hand it back to me, and that was really excellent. This whole handout thing's pretty complicated, folks. Hang in there with us.
Thanks. Run that now. I'm sure.
Oh, here we go. All right, I got it. Well, Doug, are you ready to go?
Yes. Can you hear me?
I can. I'm gonna back out and mute myself, and Doug, I'll be your man running the slides. But tell us about this. Doug Snelson. Tell us about North.
Okay. My name's Doug Snelson. I've been with the city of Norris here at the wastewater plant for about 20 years now. You know how time gets away from us. We've got an older Smith and Loveless plant, which looks like a big donut, I guess, the main part of it. Influent comes in. Yes, right in there. Yep, thank you. And it goes counterclockwise around the outer ring to a point just short of the influent, and there's a dividing wall that you can't see real good, and then it goes into the center clarifier, and from there leaves the plant and goes to a chlorine contact chamber where we disinfect with chlorine, and then we dechlorinate with sulfur dioxide. And from there it goes to Buffalo Creek, the discharge to Buffalo Creek. To start out with the nitrogen removal was accomplished, I say pretty easy, I guess, with on-off aeration in the outer ring of our plant. Seems like pretty much about 3 hours on and an hour off. We did invest early on in an ORP meter, and we would try to gain plus 100 millivolts ORP, and then air off, try to get to negative 100 millivolts, and that seemed to bring our nitrogen down. I say pretty easy. It's something that has to be monitored. I got real comfortable with it one fall and kind of lost nitrogen removal a little bit. And the deal was I was holding a lot more dissolved oxygen as the tanks cooled off. And I had to get the ORP meter back out and go back to the basics. And it required a little more off time in the cooler weather. But nitrogen came pretty easy, I think. Of course, we started air off, just manually turning the blower off and on. And then, of course, since then, we've had timers put on the blowers. And we can just set those manually whatever we need for the season. Phosphorus removal, we eased into that. I think, Grant, you kind of helped us with a side stream fermenter, which was those two 300-gallon totes. And at first we would fill them with RAS and hold them anywhere from 24 to 72 hours, and then discharge them back into the aeration. And that did work. It did work at certain times of year, seemed like, better than others. I guess Brett Ward from MTAS come by and saw a compartment in the aeration, and he said, why don't we see if we can make an in-stream fermenter? And that's what we did. What we did was valve off the air diffusers in that section and monitored that. We had some convenient partitions in that outer ring because this old Smith and Lovelace plant used to be free air, aeration, and a digester. Sometime before my time, it was all converted. The partitions, two of the partitions had windows cut in them, and it was all made extended aeration to remove ammonia. Sometime before I got here, so we had a partition, and we would let it ferment. Yes, there's a partition right there, and we would kind of watch the ORP in the fermentation zone, and of course we were shooting for negative 200 to negative 250 millivolts, and it did that pretty easy. It took a while, I guess, and also we found out we had to mix the firm zone at least once a day, I guess, to kind of stir it up and send it downstream. And by doing that, we, especially in cool weather, really did get some good phosphorus removal. The return comes from the center of the clarifier and comes back around to the head of the firm zone through this pipe right there. The downside to that is we had to watch about sending the DO from the clarifier back into the firm zone, which we don't want. So I cut a T in right there over the partition and put most of the return back into the aeration. I can adjust that. That T was put in with two Fernco couplings, and I can roll that T up and down to adjust how much goes into the aeration and how much I let go on around back into the head of the firm zone, which right now I've got about 30% going back into the head of the firm zone and 70% going into the aeration. Seems to work great in cool weather. As it starts warming up, what I have done was enhance the firm zone with the side stream totes. And as of late, I've been putting influent in the totes and holding it there again anywhere from 24 to 72 hours, and then releasing them into the firm zone. And that seems to enhance the firm zone a little bit. It's not fail-proof, but it helps. And I guess that's it on our efforts.
So these are the kind of numbers, right, that you're getting. It's you started out around 4 milligrams a liter when you first started tinkering with this thing, and pretty much just been on a steady decline, kind of flattened out here in the last year, but not really. You've got some real good numbers, I think, until things went bad on you. Maybe you want to talk a little bit about how things went a little bit bad over the winter for you?
Okay. We had filaments invade our plant. And we think that the fermentation zone was kind of a breeding ground for filaments, if you will. And I should have noticed it quicker, but it kind of got out of control before I did decide what was going on. And now, in the past 3, 4, 5 weeks, we've been feeding bleach to kill these filaments and are slowly getting back to where we were. Getting over the upset, maybe.
So my experience has been, and of course my experience is from afar, working with people in plants around the country, but most folks, if they have a strongly aerobic zone and a fermented zone, usually the filaments that like a low DO, they get killed off in the high DO zone, and vice versa. The low DO filaments get killed off in the high DO. And this is really an exception. And Doug and I were talking about it. My speculation is that probably just sat there didn't get enough good mixing. And if you periodically blow some of those solids out of there and move them on, once he gets ahead of this, I'm hoping that it won't recur. Now, a lot of folks would throw up the towel. Is that the right? Throw up the towel. That isn't right expression. What is that? Throw out the towel? Anyway, they give up. But Doug said he ain't giving up. He's gonna try again, right, Doug?
Yes, absolutely. What's kind of ironic about it, right before the filaments, it was working as great as it ever had.
Okay. All right. I like the story. It's a small plant. It's a real hands-on facility. It's a very good example of a facility. It was designed only for ammonia removal, getting great nitrogen removal, right? Where's that nitrogen removal graph? Back up to that. Didn't have really much nitrogen data before you started, so you don't really know what it was, but I'm sure it was well over 20. But of late, you're consistently below 10. Bear with me as I run through all these slides. And then the phosphorus on a great decline. So, any questions or comments from anyone? No. Anything else, Doug, you want to say? I think it was a great presentation. Again, if we were in a classroom, we have a standing ovation for you. That was a great presentation, and even more than that, great effort. I like to say machines treat sewage, but it's people who make clean water. And Doug and Tony Wilkerson and the support that the administration's given there to Doug for doing all this work. And credits to them for this good effort. Any questions or comments from anybody?
Yes.
Anything else, Doug, from you? No. All right, I'm hearing nothing. So we have one more polling question, and why don't you put that up? And while we're doing the polling question, I mean, this is like, we couldn't have timed it better. Time for a 5-minute break, so we'll put that up, give you 5 minutes to work on that. How's that?
I think it's a good idea. Let me get this poll going.
All right, we'll be back at, Eastern time where I am, 5 after noon, 5 after 11 in Central time.
So here's the poll. Have you visited the Tennessee Plant Optimization Program website before this training? Simple yes or no. So yeah, we'll give this 5 minutes. and we'll be back.
Hey, Mark, if you give it back to me, then I'll put a couple of slides on that TNPOP program, and then you can take it back. How's that?
All right. Let me try to throw it to you and see if this poll stays open.
Okay. Keep it open for the poll. That's more important. Yeah.
Okay.
Never mind. Okay, sorry.
A few more seconds and we'll be closing this poll. Alright, we're ending this poll. I'm going to publish these results and Grant will have the ability to take a look at them all.
All right. Well, it's up and running, and not very many people have checked it out yet. We're gonna want to encourage that. So maybe you send it back to me, and I will. Yep, it looks like you have. So there we are. So here's a my attempt at getting a screenshot of the page. Page is kind of long, so that's the top half of it, and there's the bottom half. What there is on this page is there's links to these recordings, some of these webinars that we're doing. You can get the recording there. As you can see, there's a number of buttons, some case studies, additional resources, contact information. As Karina mentioned at the beginning, what TDEC is really striving to do is to just increase the opportunities for operators to talk amongst yourselves, to learn from what others have done, to experiment, to borrow the tools. TDEC has some great tools that would cost, I don't know, $5,000–$10,000, some equipment to buy that they'll loan you. So you can set up a benchtop system and borrow this equipment for a period of time. Each of the regional offices has one. So what she also wanted me to pass along to you was, if you up at the top there is the website. That's quite a mouthful. I just Google TDEC nutrient optimization, or TNPOP. So put in TDEC, TNPOP, TNPOP, and if you Google that, you'll get there. If you have any questions about it or at all, there's Karina's email address. She would welcome an email from you. All right, anything more on that? We're ready for our third volunteer. So Albert Solberg and Brad Roberts, they've been waiting for the moment. Your moment has arrived, fellas. So turn on your mics and tell us about your facility.
Well, hi, my name's Brad Roberts. I'm the lead operator here at Harper Valley. With me is Albert Solberg, our plant manager. We have a extended aeration treatment plant with a design flow of 10 million gallons, but an actual average flow of closer to 5. We serve about 13,800 customers. However, probably population is about 25,000. Our peak design flow is 25 million gallons, and our design hydraulic retention time is about 20 hours. However, with the lower flows, obviously it's longer. We have a 1.4 million gallon Anoxic Zone with a 6.9 million gallon aeration zone with a total of approximately 8.33 million gallons of extended aeration. If you'll go to the next slide. Here's a picture of our overview from Stata. We were experiencing a little high flows at this time at 7 million gallons due to the rain we had. We try to utilize nutrient removal by running less aerators than all 3 per ditch at a time. We've realized this. We initially went for this for energy savings. However, we found the secondary result of nutrient removal. If you'll go to the box spacing screen where we can zoom in on that, look, that's next.
I'm sorry, I didn't hear what you just asked me to do.
Can we go to the next slide where it shows the SCADA of the aux spacing a little better? Here, if you look at our SCADA display of our oxidation basin, on the left, our raw influent mixes with our return from our clarifiers. There it enters our anoxic zone to where the microbiology uptakes the oxygen bound to nitrate nitrite. And from there, the solids will travel through the outside of the ditch into the aeration zone and travel around. That far DO probe right there near the mouth on the right is our DO measured into our clarifier. And then if you come on around there in the middle, that's our DO probe letting us know the DO going into our anoxic zone. During winter months, we're able to use one aerator. We usually use the outside VFD aerators to maintain the DO we desire of a 0.2 to 0.9. However, in the winter, obviously, we need more aerators. And also, in summer, we require more aerators through more activity. However, in the winter, we do have to turn on more to fluff it up so we don't get settling in dead spots in our solid settle out. We'll also occasionally use on-off air during high flows to help with the clarifier loading of solids, and which also helps with the denitrification. And then we'll also sequence the aerators different. Normally we keep these two aerators on the far right off, but sometimes we will turn those on and then turn off aerators 2 and 4. We just kind of adjust it as the truck to maintain our DO parameters we desire. So go to the next slide. So normally we have an average of a 30 influent milligram per liter of nitrogen with an effluent of 4.2 average, which is approximately 87% removal rate. On our TKN, we normally have really good numbers on our effluent removal. I believe the Anoxic Zone is doing a really good job. However, our nitrite sometimes doesn't have as good as removal. However, we believe that's from underloading of BOD. Most of the times on the TKN and ammonia, though, our effluent has below detectable limits, which is really good. And if you'll go to the chart we made. In the summer, obviously our nitrogen levels are a little higher, and we have better removal in the winter. Let's go to phosphorus. Our average influent phosphorus is only 3.4, with the average effluent is a 1.5. Our removal, that's a little less, 56%. Sometimes we have a water plant, no backwash filters, and it drains into our main lift station, which will pump alum over to our plant, which we believe helps bind the phosphorus for removal through the sludge. And then if you go to your chart for the phosphorus, we normally have pretty low phosphorus. We did have that one spike, I believe that was last August. We're uncertain of that right now. Thinking maybe a lab error. And I believe that's about, originally we were trying to find energy efficient to lower our footprint of energy consumption. However, through utilizing that, we were able to observe nutrient removal, which is also a double benefit of that. And how we save the energy is by cutting off those aerators, as I said before, and minimizing the aerators required for optimum performance. And I believe that's all I have on that.
Well, you're not getting off that easy, but it was very well done. Thank you for that. Anybody listening in have any questions or comments?
We had a question in the chat asking how much energy did you save and how did you measure the savings?
It was done through finance using our NES bill. However, those aerators, there's 3 per ditch, so when you cut one off, we were able to save 30% of aeration electricity costs through cutting those off and leaving those off for the majority of the year. Could you go to the overview? Yeah, that one. We also have the same aerators in our digesters, and at the time we were running those consistently, except for cutting them off to decant. And by turning those off, that also helps with the efficiency. 12 hours on and 12 hours off. This process was started before I hired in here. I hired in 2015, so I'm not quite sure of the exact numbers that were accomplished. However, our financial department loves it.
always nice to keep them happy, right?
Oh yeah.
One less enemy. Any other questions or comments? Well, let's see, what do we have here? So, let's look at this aerial view. So, the plan is designed that this is a low oxygen zone for nitrate removal, right? That's the nitrate removal.
Correct.
And the nitrates get created in the main body of the ditch when you remove ammonia.
Correct.
And then your schematic shows nicely how the flow moves between the aerobic zone and the anoxic zone to allow that denitrification. Now, the phosphorus removal, you said that you're getting alum sludge from the water plant, and the alum is, you suspect, and I would certainly feel the same way, that's binding up some of the phosphorus. So the phosphorus removal you're getting is largely due to a chemical treatment by the alum.
Right.
Right?
Subconsciously. Yes, sir.
Subconsciously, right.
We don't get to control that flow.
So it removes whatever it removes. And then the plant itself, you don't think is doing a lot for biological phosphorus removal. Those numbers for phosphorus removal here are, like I said, subconscious. They're happenstance. Sometimes really good, sometimes not bad, but just not as good. Do you have limits on nitrogen and phosphorus?
No, sir, not currently.
You have ammonia limit?
No, sir.
Okay, so you don't have any nitrogen or phosphorus limits, and that's why you said that when you started this, you were doing it as a cost savings approach.
Right. We discharge to the Cumberland River, which is quite large.
And you got a lot of mixers and aerators. So if you've got, just counting them on this one, you've got 1, 2, 3, 4 mixers. You don't know offhand what the horsepower on those is, do you? That's fine if you don't.
I believe they're 25.
25 horsepower mixers. Wow. And then your aerators?
75 horses. Or 150, I believe.
That's a lot of
They're
horsepower.
quite large.
Yeah, that's a lot of horsepower.
As tall as I am.
Okay. And then the ones in your previous slide here, the ones over here, they're pretty big too?
Yes, sir. They're the same size as the oxidation basin.
Okay, there's a lot of horsepower. You got 1, 2,
Correct.
3, 4, 5, 6, 7, 8, 9. Did I count that right? 9.
It should be,
9.
9.
7, 8, 9. Yeah, you got 9 of these 100 plus 100. What did you say? 150 horsepower.
Yes, sir.
And then these are 25s, and is this one a 25 here too?
That's actually a thickener. It's almost like a clarifier scraper to thicken up the sludge in the digester. So it's not.
That's more like a drive on a clarifier. Okay.
Yes, sir.
All right. So you've already made huge steps with reducing your electrical use. What is your ammonia year-round? Do you see a change in ammonia summer to winter? Effluent ammonia?
A lot of times it's detectable in our lab results. I've been looking through several months and I haven't been able to find one that was detectable so far.
Okay. And if you've been looking in the winter, which if anything would be the lower numbers, one would think, right?
Correct.
Well, I guess if you didn't give enough air in the summer, then it would go up. But so you're killing it for ammonia removal.
So January of 2020, it was non-detectable, and then same in December of 2019.
So let me tell you something that I've been playing with, and there's going to be an article in TPO magazine, maybe out now. I haven't checked in a week or so. About Great Bend, Kansas. Great Bend, Kansas has an oxidation ditch, kind of sort of like yours, okay? The kind of sort of like your part is it has a pre-anoxic zone and has an aeration zone. It's not bent back on itself like yours is. But other than that, it's the same concept. Aerobic zone, anoxic zone. So this design is for nitrogen removal. It is not for phosphorus removal.
Correct.
Right? Oxidation ditches for phosphorus removal have a whole other set of anaerobic tanks that they put on them. But I'm thinking you should be able to get your nitrification and denitrification in the main body here. Cookville, Tennessee is a great example of how that was done. It's not configured quite the same as yours, like the Great Bend plan is. But in Great Bend, now your aeration equipment, is it 6-speed or is it VFD?
Aerators 1 and 5 are on VFD. Aerators 2, 3, 4, and 6 are on high or low speed.
Okay. All right. So these 4 have 3 speeds: on, or high, low, or off. So they're really 2 speeds, or off. And then the outer ones here, you can control the speed.
Correct.
The DO probes, are they tied in to any of those equipment? Do they control?
They are. We found that it functions better if we control the weir height of the oxidation basin and the speed and aerators running to maintain the DO. We haven't quite got the formula in the SCADA system to operate the oxidation ditch the way that we desire.
So what do you have, like a little chart that you use and that helps you figure out raise or lower it?
It's got an algorithm in it to where it'll ramp up all the aerators to high speed before it starts adjusting the weir height. And we would like for the weir height to be adjusted before turning all the aerators to high speed. That's something we're actually currently working on with our IT people.
Oh, that's pretty neat. Okay, can you explain to people what the different water depth does in an oxidation ditch? Probably a lot of folks aren't familiar with that.
We have approximately a 12-inch difference between the bottom of the weir height to the top, which that does our aerators are surface aerators, and so therefore if you submerge the aerator more, you get a more efficient aeration throughout the entire oxidation basin. So the lower the level, the less DO gets input into the basin, and the higher the level, the more DO you get.
So it's kind of counterintuitive. So you would think the deeper the water, the less dissolved oxygen, but the deeper the rotors are digging into the water, right? They're bringing the water up. So that's why a higher water level will give you a higher dissolved oxygen.
Correct.
That's pretty, you know, I've been to a lot of plants that have adjustable weirs, and I would say 24 plants maybe. I'm just guessing. And you're the only one that really uses the weir depth. So that a lot of plants are equipped with it, and it's been abandoned so long ago that they're rusted in place. So it's very interesting that you're still doing that you're putting it to use. I think what we're going to want to do, what I'm curious about doing is if we can nitrify and denitrify in here, create a low oxygen zone and a high oxygen zone. High oxygen, of course, gets rid of the ammonia, and then the low oxygen gets rid of the nitrates. Then you don't need the anoxic zone for nitrogen removal. You're getting it all done over here. Then you can let this thing get more septic. And how do you do that? You do that by turning those mixers off, which they're not as big a energy use as your aerators, but that adds up. You know, if they're 25 each, there's 100 horse right there. So run those less than full time. Allow on purpose a little bit of sludge blanket in these so-called anoxic zones. Drive the ORP, kind of like Doug was talking about there in north. Make it a little more, ever more anaerobic. Then maybe you can get some biological phosphorus removal, get some VFA production, and start to cultivate the bacteria, IOP bugs, I call them, the PAOs, the smart people call them. Get those bacteria growing to feed on the VFAs, and then as they shoot into the aeration tank, they would hit the high DO, and you get some biological phosphorus removal to supplement that you're getting chemically. And you do it cheaper because you're running less equipment. So that's going to be the game that I'm going to try to entice you to play here over the next year when I first visit and we start talking about it. I think you may have some real opportunities here to further your energy savings, and in doing so, get some more consistent, more in your control phosphorus removal. So what do you think of that?
How long of a duration would you believe needed to turn off those mixers to accomplish the anoxic or the anaerobic zone?
Okay, well, I'm going to give you a range. Put a gun to my head, I'd say you'd leave them off all but about an hour a day. So probably how I would start, however, is I would turn one of them off in each basin, and every day I'd switch. So in basin 1, I'd run 1 on Mondays, 2 would be off on Mondays. On Tuesdays, I'd turn on 2 and turn off 1. I'd try that for a little while and see if just get comfortable with it, right? Because that's a big change from what you're doing. And then if you're finding your mixed liquor isn't falling out in here and you're not seeing any real problems from that, then I'd have them both off for the majority of the time. So we're not going to be saving, you wouldn't be saving 100 horsepower around the clock, but you'd probably save 75 horsepower around the clock. So you could do the math on that and see what kind of energy savings that would be. And probably at the same time, it's possible you're doing more aeration than you need here, because if your ammonias are typically non-detect and you don't have an ammonia limit, well, let's gamble a little bit. Let's see what happens if your ammonia climbs up to 1 or 2. Can we drop your total nitrogen down and do so with less electricity? Your total nitrogen would be less. You'd be spending less electricity here. So there'd be both of those things I'd be looking into. But yeah, I'd start with just turning one off at a time, seeing what happens as far as the mixers goes. And then we can look over here as a digester. Okay, they're on half the time. What if they're on a third of the time or a quarter of the time? You know, you probably have a good reason why you're doing it now, so I'll just be asking those questions. Nice, it's a nice, looks like a nice plant. What were the flows compared to the design?
About half. So the average flow is about half of the design flow.
Okay, so you've got about almost 2 days retention time in your ditch, right?
Correct. Depending on flow, obviously.
Yeah. Yeah. All right, I'm looking forward to that. That's a great presentation, good plant. You guys are doing great with it. Maybe you can do a little better. Not do a little better. Maybe there's some more tricks here to try it. So that'll be fun. All right, anybody else have any questions or comments? Nothing coming in. Anything else you guys want to say?
Look forward to seeing you in a couple of weeks.
Brad, Albert, thank you so much. That was really great. Once again, I wish we were in a classroom so you could get your recognition. Cause, I'm sure folks listening in appreciate hearing your story.
Thank you.
Thank you. Well, here we are. We've got 15 minutes to go. I think there was some kind of communication goof up. And is there anyone from McMinnville ready to present? I think that's probably on me that didn't coordinate that properly. We may be without anyone from McMinnville. Am I correct, or is there someone there?
What was the name again, Grant? I could look down the line.
The name is Phil Miller.
Yeah, I do not see a Phil.
Well, here's something I'm going to put out there, and given the paucity of comments, I'm thinking I'm going to be whistling in the dark. But if there's anybody, see, if we were in the classroom, what I'd be doing now is trying to catch one of your eyes and say, why don't you come up here and talk about your plant? If anybody wants to talk about their plant, I can quick whip over to Google Maps, and we can get a picture of your plant and talk about it. Is there anybody listening in wants to do that? If there is, raise your hand. Click the raise your hand button or type something to Mark and Bree and Allie. You seen anything from anybody, Mark?
Nothing yet. And I know there was a comment, I think this was just addressed, I just want to make sure, with the no nutrient limits, you could possibly save money by using VFDs or, checking your horsepower and lowering horsepower.
Yeah. The VFDs will allow you, of course, instead of running a high or low, you can run some in-between speed or even go lower than low sometimes.
Is there a method to find that sweet spot, Grant, if you're running a VFD?
Yeah, there is a method. Methods trial and error, but informed trial and error. So let's look here. Problem with an oxidation ditch, particularly one that bends back on itself like this, is where can you access the ditch? Can you access anywhere in this zone? For example, if there's a catwalk, maybe that's a catwalk, I can't tell, you could, and there's another catwalk. Yep.
Yeah, so those are the catwalks.
Okay, so you got a catwalk, so you can go on either side of the catwalk, so you can run any of those. How far off the ground is this wall here? Is it very high?
It's maybe 3 to 4 feet. It's probably about waist to chest high, not very.
Same over here?
Yes, sir. It's all about level there, all around.
So that's a nice feature. So in this plant, and a lot of ditches, they're not like this. This plant, you can pretty much walk the perimeter and get put your ORP or DO probe in, and you've got catwalk. So you can measure it pretty well. You can get a good understanding of how what the dissolved oxygen is going through the plant. So back to your question, Mark. If I want to get this right. So Brad, it go this way? It goes
yes, sir. No, it goes the opposite direction.
Opposite
The inside, it goes towards the Anoxic Zone.
Okay, and it goes around like that.
Correct.
Okay. All right. So to answer Mark's question, how do you know how to set things? Well, the flow's going in, through, out, and around here. So you turn this rotor on, and you get your high DO. There's another rotor that's going to boost the DO.
That's actually another part of the channel. That one doesn't affect that outside area.
Oh, yep, you're right. Okay, I'm sorry. Okay, my mistake. Of course you're right. So it goes up and around. You're not getting another boost until you get all the way to here.
Correct.
Then this short run, and then another boost, short run. So the high dissolved oxygen levels would be, since these are a lot closer together, one would think this area would probably have the highest dissolved oxygen. And the lowest would be in this area here, right?
Right.
So what I would want to do is I'd want to do a profile. I'd get my DO probe, my ORP probe, and I would measure what's the DO here, what's the DO here, same for ORP, maybe a couple places here. And of course it's going to change, depends upon temperature, loading, flow, but I just get an idea of what's happening as it goes all the way around this here plant. And then I would want to create a strongly aerobic zone for ammonia removal, which you've already got. So since you're already removing ammonia, what we're really starting to do is take away oxygen. And I would want to take away oxygen with that rotor right there. That's the rotor. Is that one on VFD?
Yes, sir.
All right. So that's the one, because if that's, see, you got the short run here between rotors, the short run there between rotors. This is going to be your high DO zone. So you want your ammonia removal here. You want your nitrate removal here. And this rotor is the one that's going to control how low you can go. So we want to run this one enough. We probably want to run this one a very little and have this zone be our anoxic zone. So I'd run a profile around, and I'd see at what speed do I need to keep this guy so that my ORP is nice and low. And then I'd just it'd be an iterative thing. I'd change it. Keep these two running. Do these typically run on high or low?
We try to maintain low on all of them. The VFDs will only run down to 75%, and which is where we try to keep it.
All right. So if these...
But everything stays low.
Go ahead.
Oh, so I was just saying, we try to keep all aerators on low when they are in operation.
You have timers on them so they can turn on and off.
No.
Are you comfortable with the idea of turning them on and off, or do you not like that idea?
We do currently,
Okay.
depending on the situation.
Okay. Some people don't like it. They don't like starting them, but after they see the energy savings, they usually can get their minds changed. So to answer Mark's question, I'm going to want to profile through the plant, and then I'm going to want to see what happens. There's a guy in Ohio who's been doing webinars where he calls it empirical, and he's right. So this is empirical. You try it and see what happens. And forget all this modeling stuff. So running them 2 on low and running that one off for a while. Run this one off. What happens? Am I still getting my ammonia removal? Yes or no? As long as I'm still getting my ammonia removal, then I've got sufficient air. Then I'd start looking at timers on these. If I can run this off and still get my ammonia removal, then I'm going to want to try timers. And I'm going to just want to boost this denitrification zone. And as that gets boosted, this becomes ever more irrelevant. As this becomes irrelevant as far as nitrogen goes, then I'm going to be doing testing there. This is going to have to be ORP because the DOs are going to be so low. And that's the no mixing and seeing if I can start to get the phosphorus removal. So it's a very long-winded answer, but I don't have, it's really a trial and error effort to see what works best for you. And I can see what you're saying in this one. We've got the added complexity of the water depth, what to do with the water depth, and how to kind of fit that into your thinking. Well, when you have the higher water, this is something I don't have much experience with it, but they have more drag on the aerator, I would suspect. Do you get a bigger energy draw on the aerator when the water's higher? You ever notice that? All right.
We don't normally have access to the energy bill on a current or regular basis, so we're unable to really notice a difference in the day-to-day.
Yeah. Okay. Okay. So you actually dropped the water level as a way to reduce the DO then. Why would you drop the water level? Why do you drop the water level?
We try to run 2 aerators in each ditch, and if both aerators, like especially in winter months, maintain a higher DO than we desire, we will lower that water level to get to a parameter we prefer.
Oh, okay. Okay. And
so in the winter, they normally ride up a lot higher than, say, winter times.
Okay. So your DO...
Yeah, summertime, sorry, yes.
So your DO gets high in the winter, so that you don't have such a high DO, you drop the water level.
Correct.
Okay. All right.
If we run one aerator, the solids will settle out into the oxidation basin, so we try to keep 2 running to kind of fluff it up. Make sure it makes it to the clarifiers.
Yep. Okay. And if some solids settle out, will they resuspend when you turn the rotor back on?
Yes, sir.
Okay. So I'm going to try to sell you on the proposition of getting comfortable with the solids settling out, knowing they'll resuspend when the rotors come back on. So what if they settle out? Except that all your life you've been told that shouldn't happen. So that's what I'm going to try to sell you on that a little bit. Maybe get some comfort that that's a possibility. Now in Cookville, if you remember that case study, Cookville has 6 rotors, the horizontal shaft instead of vertical shaft, per ditch, and they now run with only 2 of the 6 at any one point in time, and they believe they are getting settling out. A few months after they started that, they had the biggest flow ever through the plant, and it did not blow any solids out. In fact, they said they handled it as well as ever. So, so that's something kind of challenge ourselves on, if that's something we can think about doing out. Well, I think with that, we were able, anybody have anything else? I'm going to run all the way to the end here. Looks like a lot of people to thank, particularly the volunteers today. Thank you guys so much for sharing about your plants. I know we're in the business. Our business is not select for people who want to shine a light on themselves. It's not that kind of business. So to have operators step forward and share their experiences with other operators is just particularly satisfying. So thank you so much for doing that. Our series is all but done. We have one final polling question about kind of where you'd like to go with all of this. So why don't I give it back to you, Mark, to do that?
All righty, I'll jump on the poll. Okay, this poll is, do you want to come back and hear how these plants optimize their operations? I totally do. So we'll close this poll out in a few. Grant, I don't know if you want to discuss it or not. I know Karina has some closing remarks, so once this poll completes, I think we'll have Karina jump on.
Oops, I had myself muted. Whatever works best for you, I'm all in. Let's hear from Karina if she's back. I knew she had to go somewhere.
Oh yes, you're correct. If not, I can close this out. You and I can close it out, Grant.
Okay. Yep.
Oh no, I'm saying it just looks like everyone's finishing up, so I'm going to close this poll here in a few seconds.
Yeah, I'm anxious to see. All right, we have 5 honest people. So thank you. This is Karina Bynum. There's a clever way of getting one more webinar out of her consultant. So, but we'll have to do it. we'll have to do this. I think we've done our wrap up. Just tremendous, and again, thanks everybody for 50 of you plus, I think, coming in with a little notice to modify the schedule and come back this week. 53 people, plus the panelists who are always behind the scenes, done a great job. So thank you for that. That wraps up this series, unless we're going to have some revisiting the treatment plants and hearing their stories, 6-9 months later.
Yeah, so thank you very much, everybody. Once again, if you need to get your CEUs, please email Allie with all the list of attendees that were with you, their names and their license numbers, and Allie can get that set up for y'all. Again, her email is Allie, ALLE.Crampton, CRAMPTON @TN.gov. So once again, thank you, everybody. I'm going to be switching the host mode back to Allie, and she can do the wrap-up of everything else with this webinar, just closing everything out.
All right, thank you and goodbye.
Goodbye, everybody. Have a great day.